Okay, let me get started here. First of all, any questions about homework 3? How many people have gotten started on homework 3? A few people, actually more than I thought, so I'll say I'm impressed with that. Any questions about it? How many people are seeing that have gotten as far as to get, let's say, the NLP, the vision embeddings out? Okay, a bunch of people. And are they behaving for you guys what you would kind of expect? That it does a decent job of doing the classification and the picture looks good? Or is it that this is a complete mess? Who here said that who had done it, who looked at these things, says they're looking at things and they're seeing clusters and they're seeing something happening? No one. Who here is saying they're seeing complete mess? Okay, this is a surprise, because when we did it, we did not see a complete mess. And I'm going to do a little test a little later in the class of whether you're seeing a complete mess or not. But any questions about the homework other than that? Okay, it's good to get started and clear that. But this is a surprise, okay? And we will try to clarify that. Okay, anything else on homework 3? Okay, what I'd like to do to start off is to talk about the course projects. So this is, what has to be done this semester before you can kind of put this course to bed. We have a homework 3 that is due in, I want to say, a week to 2 weeks, correct? We then have a week after that, you have to turn in a 3-page project proposal, okay? And part of you may say 3 pages, that's nothing. It's important that you think through what your project proposal is. I'm going through this today. So although you'll be graded on it, and although it's only 3 pages, and you may say ChatGPT can write that, it's important to kind of do this carefully to make sure you've got a project that you're able to do, okay? That you've worked out kind of the roadblocks that will prevent you from doing a decent project. And then these will be graded fairly quickly, and then as of the last day of class, you will have to turn in the actual final write-up, which I think I said is 8 pages long. Okay? Any questions about that? So the projects are supposed to be done in groups, okay? I like groups of 2 or 3. I do not like groups of 1, because I do think that it is good to interact with somebody on a project like that. And I also really don't like groups of 4 or more, okay? Because I think that, these projects are of sufficiently bounded size that I don't think it helps to have larger groups. I will do an analysis of what the scores are on projects independent of group size. And if I find, again, theoretically, a project with 3 people should be better than a project with 2 people. If I find that there is some kind of skewing of scores where I will correct for the group size on some way at the end, okay? So if we find that 3-people projects all score wildly better than 2-people projects, that's how it should be in real world, in the ideal world, okay? And if so, we would then scale down the 3-people projects, to give more weight to the 2-people projects. Usually there is not that much of a difference, to be honest with you, okay? Any questions about that? Okay, so what is my experience? Again, I encourage you to read this, okay, the handout. I'm going to go through the project topic soon, but I'm going to tell you what I find that I always find amazing. You guys are going to go spontaneously, go off and form groups. You're going to go look at my list of projects. I'm going to tell you which ones I think are the ones which are the most exciting and have the most opportunity to do something interesting. You guys will systematically evaluate them. and you will all heard on the boring project where there is nothing to do. This is my sense is from the past classes. We'll see whether that happens this year. Some of these projects are, more open-ended and have bigger possibilities of doing something. Those I personally think are more interesting. Some of them will be very, very tightly conscripted, and there doesn't seem to be anything too brilliant to do, okay? And, you can pick this if you want, okay? And my guess is that many of you will pick that. But I think that then what you will often find is that, when you do the project, you're not that excited about it. What you've done is not look really that great, okay? And you will decide. Any questions about that? We'll decide if I give you any hints how I think. Again, I encourage you to follow what I think. I'll also tell you most classes don't, okay? What I will tell you is during this evaluation time, why am I giving you so much time to write a 3-page paper as a group? The reason is I want you to kind of, think about multiple project options during the period. I want you to show that you have some kind of preliminary results. Just basically because when you have preliminary results, you'll have some confidence you'll be able to do something. It could very well be you pick a project, you get any preliminary results. You then go and try to do it the week before the end of the semester and suddenly discover you can't get the data set. There's no data available for my project. I don't know what to do. That's what we need to avoid by you having kind of worked that through in the thing. I like to have groups, the projects roughly balanced by the number of people doing it. If I see one project everybody herds on, and it is a chance I may take people with the weakest proposals and tell them to go do something else in the second phase. That sometimes happens, but we'll see. I don't expect anywhere near perfect balance, but we'll see. To preserve anonymity for when at least the grader TAs are grading it, make sure you don't include your names or ID numbers on the on the papers. We are going to send out a form, okay, for you to fill out. Every group's going to have to submit a group registration form on Google Classroom, and that's how we're going to know what names map with what projects. Any questions? Okay, I will warn you that on the at the end of the project, I'm going to have group members have to describe how they partition the credit among the members of the group. So if you're working with a partner, you'd like that partner, you and that partner, to be 50-50, okay? Or you'd like to be in agreement that this guy didn't really do so much, this was the one that carried it. When I look at how you guys split the grades, if there's inconsistencies, I will track it down and make you guys come to an agreement. Okay, so we'll talk about that later. I don't think we're going to use peer grading here. So my plan is this semester, I think we have enough TAs and there's usually enough reaction against peer grading. I think we're going to be able to get by with the TAs and I doing the grading. Any questions about the rules, first of all? So what I'd like to talk about are some of my project ideas. And so when you look at each entry, you will see there is a captain. What is the captain? The captain is a TA's name who you should probably direct questions to as a first procedure. So this is the one who will be fielding the, any questions about that project, and likely, but not certainly, be the one that's grading it. For each project, I give a recommendation of what kind of people I think this is good for, okay? It's not force of law. If I said that this was good for MS students and PhD student was dying to do it, that's fine. Same is true vice versa. But this is my sense. And I give a subtle red thing here if I really like this project. Okay? That may mean you don't want to do it, but that's what I think. Okay? Any questions about that? Okay. So the first one is about, and again, some of these are going to use, there's different ones that are going to use different things that you may or may not know about. You factor your skills in them. Okay. I assume people know what vanity license plates are, correct? Some people have a license plate on their car that spells something out, okay? And they usually do it in very cryptic ways. I don't know if you've seen it. Trying to figure out what a vanity license plate is saying is an interesting task. And so that's kind of what I want you to do. I want you to take a look at, find a database of vanity license plates. Obviously, the bigger the better. There is something available from New York State. I was impressed that it came out because of a Freedom of Information Act law. You may remember we talked about where data comes from early on. Government records, if they don't cause any, if they don't violate privacy, you can appeal that the government release them. And so this is like a list of all the requested vanity license plates that went to New York State. Now, some of them might be, people may make requests that get refused. Suppose you have a dirty word you want on your license plate, okay? They will not let you do that, okay? But basically the question is, do something with license plate data and LLMs. And what do I want to see? I might be interested in, is there a categorization of what kinds of license plates people request? Okay, that makes sense. That feels like something to know about. I, by the way, have always wanted the license plate. I never bothered to pay the money for it, but I always wanted the license plate NP hard. Does anyone know what would that be interpreted as? Again, I'm an algorithms person. I'm happen to enjoy proving things NP complete. Would someone recognize it? How does it deal with? Okay, given a license number, can you tell whether it's personalized or randomly allocated, meaning allocated by the state? Okay, there are some rules by how license plates are constructed. Given a vanity license plate, can you tell what it really means? It would be interesting to spell it out. If you saw NP hard, you would like the system to maybe tell you this guy must be a theoretical computer scientist or something like that. Okay? Given a license plate, tell me whether it's obscene or illegal. Okay, so these are the kinds of questions that I might want you to answer. And what I need you to discuss in your proposal, if you're going to do this project, I need to know what are your data sources. Okay, I give one link. Okay, that doesn't mean that that's the ultimate data source that is out there. Okay, that doesn't have mappings to what these things mean, for example. Okay, but you should be able to do it. You should do a literature search. I am sure there are people who've written papers on this. It may be there's a perfect system out there you can find, in which case this is probably not as great a project as I think it is, right? You will need to express how you're going to evaluate how you're doing. Okay, this may not be so easy for this project. Okay, and so you got to show that you've thought that through. Okay, ideally you'll have done some kind of a preliminary experiment or data analysis just to see how bad a dumb thing works. Okay, what would be a dumb way dumb meaning simple, not dumb meaning anyone who tries this is an idiot. What would be a simple way to try to interpret what a license plate means? Can anyone come up with a simple way, a baseline thing? Yeah? Search for words in the dictionary. That's exactly what I was thinking, okay? Now, obviously, you'd like to do better than that, okay? But that starts to be a start, right? And again, you should then have some kind of a vision of how you would do better. Maybe using LLMs, probably using LLMs in some kind of a way, okay? Any questions? Okay, any questions about the project on the license plates? Okay, good. A second project that I like, as you notice this thing here, has to do with analyzing business logos. You guys are familiar, every business has some kind of a logo for it that appears on their stationery, it may appear on their website. What is the logo for McDonald's? Does anyone have a concept of McDonald's? I'm seeing some waving thing, right? I am seeing a yellow waving thing, the golden arches, right? Okay. Does Apple have a symbol? Yes. Does every sleazy startup company in the world have a symbol? And the answer is almost everyone does, okay? And the question now is, can you look at a database of logo images? We had a guy who I work with assembled a database of 1 million company logo images from Crunchbase. Crunchbase is something that seems to analyze startup companies or something like that. And, we were trying to look at, could you tell whether more successful companies had better logos, okay? It's not crazy to me. So, and what do we mean by more successful? Most of these million companies are startups. What happens to startup companies? Does anyone know what happens to startup companies? They go out of business. That's generally what happens to them, okay? Some of them get money and get successful. They raise money. Some of them go out of business. Some of that data is available in Crunchbase. A successful company is one that would get funding or one that succeeded in not going out of business. Does everybody kind of get that idea? You can have higher standards of success. But the question now is, for example, can you predict which companies will be successful from their logo alone? Now, this sounds crazy, but it's not as crazy as it sounds. Certainly, I imagine there is a difference between a logo made by the founder's kid and a logo made by a professional designer, okay? And do I think that the companies with the logos made by the professional designer do better? Maybe. I think so, okay? So what would you do with this? Can you, first of all, given a logo, can you tell what business it's in? When you see the McDonald's Golden Arch, can you say that obviously denotes a restaurant, okay? Or is that a high-tech company, okay? So can you do tech logos look different than other companies, okay? Which company will be successful from its logo? Can you tell the difference between an American company and an international company from looking at its logo? I think you can to a certain extent. If it has Japanese writing in it, probably. It's probably less likely to be American, but not certain, okay? Okay, can you cluster the logos in a natural way? Okay, what logos are similar to what other logos? Okay, and is there a taxonomy that naturally can be formed of what logos look like? And which are the best and which are the worst in some defensible way? Any questions about logos? What do I want in a project report like that? I would like to see, I'd like to see that you have the data and that you've played with it and you've underlined it and you've done something with it. The data I link to is kind of old. Maybe you want to show that you can get a better data set. Maybe you can find a better data set of what happens to companies, things like this. You need to do some kind of exploratory analysis that you describe in your thing. so that you have some idea of what that million logo data set looks like. If you have 1 million logos in there, a certain number of 100,000 must be complete junk. Okay, can you clean that out? Okay, can you extract simple features and understand it? Okay, you should decide which of these kind of questions you really want to answer. A good project is a one answer, one problem dealt with in depth. A bad project is a hand wave at all of these things. Does everybody get that idea? So we want to see something that's more deep, okay? And again, this is an image processing project on some level. You should get some kind of familiarity with dealing with image models. Maybe off-the-shelf ones will be fine. Logos are different than normal photographs, though. They're typically drawings, and it may or may not be that one of your models does well. These are the kind of things you want to think about. Any questions about the logo project? Okay, fair enough. The third class that I am going to want is something on Kaggle challenges. Okay, it turns out that there are 3 Kaggle challenges that are running now that are interesting. They all came in after this homework 3 started, or homework 2 or homework 3 started, or else you would have been maybe gotten one of them for a homework assignment. One of them is on data from the American football. Okay, they give you some data set about where the players are positioned on the field, what they are doing before the play starts, and based on that, can you figure out what's going to happen next? Okay, who here follows American football at all? Okay, a lot of you, I can tell. Okay, anyway, based on where different plays have players in different spots. And, you know, in principle, can you look at the location and figure out what you want to do there? Now, if you don't like American football, okay, there's 2 other Kaggle challenges that are listed there. Okay, there is one about trying to figure out they have data about how physically active somebody is and how much bad stuff they do on the internet, okay? And the question is, can you maybe predict what kids are going to be getting, showing problematic internet behavior? That's one of them. Another one was on stock market prediction. Given you have a real-time market, can you predict how the stocks are going to do? So for all of these, this involves kind of doing what do I want you to do? You need to figure out which challenge you want to work on. You should do some preliminary experiments here. You should make sure you know how you can measure what you're doing, okay, and so on. Any questions about the Kaggle challenge ones? What did I color the Kaggle challenges at the start? Hold on. Okay, sorry about that. Let's keep going. Am I doing bad? I'm going the wrong way. Sorry about this. For the Kaggle challenges, if you notice, I did not make it red, okay? That doesn't mean you can't do it. It might be interesting. You decide. But this one, it's no more open-ended than a Kaggle challenge. And, but if you're interested in one of these, by all means, go ahead. A question? Well, in this case, what would I want to know? I'd like to know that you guys are prepared to do something serious on this submission, okay? That would mean what idea of what the methods are, what your preliminary work is, what you're going to be doing, how you're going to be attacking it, okay? So, again, if you're just going to do the Kaggle challenge, there's limited opportunities for what to do next outside the challenge. But again, maybe there's visualizations you can do. Maybe there's some other interesting problem you can find related now that you got data on it. The NFL one is relatively open, actually, because they don't really specify what the statistic is or anything like that you have to generate there. But you decide. Any questions? Okay. Next one. How many people here have ever seen a horse race? Okay. So you're not as enthusiastic about horse racing as you are about NFL football, or almost a little more enthusiastic about NFL football. Horse racing is actually an interesting sport where people bet on it. That's why it's interesting. What I want you to do here is to try to develop something that can tell me how well a horse is doing in the race at any given time. Okay? So, a video of a horse race. Right here. You'd like to be able to know your horse is 3 lengths behind halfway through the race. What are the chances it's going to win? Is the kind of thing that I'd like to be able to know. And in order to do this, and it's kind of interesting because in horse racing, good horses sometimes start very far behind. Okay? Bad horses run out to the front, get tired, and then collapse. Okay? The question is, taking a look at, try to build a data set for analyzing how horse races are going on. Okay? I'm kind of interested in knowing, after every 16th of a mile, for each of the horses in the race, what is their chance of winning at this point? Okay? When the race started, probably the betting odds was the right predictor. At the end, the picture showing which horse crossed the finish line is a great predictor. What about in the middle? Okay? And so for this one, I want you to, if you're going to do this one, I want you to read something about horse racing to understand it. I want you to figure out where you're going to get your data about positions of horses in races. There's lots of videos, and so if you can do video analysis, that would be an exciting way to get data about where horses are at any moment in a race. Some other more modern racetracks, apparently they put like GPS devices on the horses or something like that so you can see where it is. Okay? So one part of the project is build a database of horse races where the horses are as a function of time. Okay? And this by itself might be a tremendous project. Okay? If there's a lot of video analysis and a lot of hard work doing data collection, this by itself is great. If you can otherwise get data about where each horse is in the race, I want you to kind of show that you can do some tabulation and analysis of this, okay? And then describe a plan of what you're doing, okay? Any questions about horse racing? Okay, no. This next project is Reddit that claims to be a Kaggle data set on an analysis of 1 million jokes that were posted to Reddit. Okay? Now, the question is, can you analyze this corpus of jokes and do something interesting with it? Can you tell me what actually is a joke? Okay, I'm sure that there's cleaning problems. Just because something was posted to Reddit's joke page probably isn't enough to say that it's a joke. Okay? Which jokes are the same joke? Okay? You can imagine that there are two jokes that really are the same, modulo maybe the name of the person or the ethnic group of the person or some aspect of the joke is structurally the same. The question of how many different types of jokes are there in the world would be an interesting question to know about. Can you tell if two jokes are the same? Can you tell the difference between clean and dirty jokes or kids' jokes from other jokes? Okay? Can you cluster the jokes and categorize them? And finally, maybe you could predict how funny a joke is. Okay? What is important to know if you're going to do this project? One is you'd better start by doing a careful look at this joke opera and see what's really there. I suspect the more you look at it, the more disappointed you will be. But that's okay. You've got a million things to start with, and there's stuff there. You should be able to do some kind of a literature search on recognizing humor with NLP. Okay? There's people who have done this kind of thing. You should think through evaluation. If you're going to tell how funny a joke is, you need some kind of a gold standard or something like that. Okay? And I'd like to see something like that. Again, you should not do the most of those tasks. You should do one task well rather than a lot of tasks bad. Okay? Any questions about the joke assignment? Okay. What other one? One of our TAs, Jignesh, contributed this one. He's interested in studying how machine learning models are trained, okay, in the bowels of these things. How do you train them? We will talk about, stochastic gradient descent and things in the next, week or two, probably about a week or two, okay? I want to know in this case, there are different strategies that are used to optimize these things. And this project is basically about trying to evaluate how these different optimization criteria work, okay, and maybe even design a better optimization criteria for training these things. What would you need to do? You'd need to do some kind of a literature search on these optimization algorithms. You're going to have to figure out which one of your tasks and training sets you're really going to play with. Okay, you're going to want to deal with baseline models and analysis using the way current optimizers work. And then think about how some kind of again, you could just do a very careful evaluation if it's well thought out. Otherwise, maybe you've got a different approach, tweak to one of these optimization methods and can see how well it does. Any questions about that one? This has the advantage that you have a TA that's excited about this, okay? And so if you're interested in these kind of things, that's good. Yes? Is there a reason why it isn't marked with a star? Wait, did I not mark it with a star? The reason I didn't mark it with a star is that it's my TA's thing. So this may reflect prejudice more than anything else, okay? And if this is it's going deeper into kind of machine learning things than we are going to do in this class. If you're interested in doing this, this is a great project, okay? So don't let my lack of red scare you here if that's what you think you want to do, okay? Any questions? Good, that's a good question, by the way. Okay. The next one is a project that I like. See, it's red. I gave it last year. It was red. One group tried it, and they made it too complicated and did a terrible job, and otherwise nobody did it. Okay? So you can decide if that makes it exciting to you or not. But what is my question here? Suppose I were to give you a set of points here. And now I ask you, what order were they generated in? Would you look at a set of points like this and say, this was the first one, this was the second one, this was the third one? Okay, probably not. You might say it was 1, 2, 3 to n or 1, 2, 3 to n. Does everybody see that? Now the question really is, if I give you a set of points, can you make a prediction of what order they were inserted in general, just giving you a picture, okay? Think back when we were looking at the painting by Jackson Pollock, right? Jackson Pollock painted, he had these drips. Remember he had these drip paintings which swirled around? Some drips were before other drips. Can you figure out what the order kind of was? Is the same thing. So in this case, you're given a set of points. They were generated by some process that inserted them in an order. And your goal is to now say, can you make a guess as to what order they were inserted in, knowing nothing else other than the points? That's kind of what my question here is. Okay? And a lot of data sets get inserted incrementally. If you look at Wikipedia, some pages got inserted into Wikipedia before other pages were inserted in Wikipedia. Okay? When you look at IMDb, okay, certain pages, entries into the movie database were made before other ones. Probably that reflected the age at which the movie was made. Okay, although not completely actually, because presumably IMDb didn't start at the very beginning of movies, right? Probably it started with hot modern movies, worked backwards for famous old movies, and then gradually filled in less famous ones. Question is, given data points, figure out the order that they were inserted. That's what I'm asking you to do. And if I go and do this, hold on. I'm sorry if I keep messing this up. Okay, what should you do? You should build some kind of do a literature search. Are there people who've done problems like this before? You should look at building a data set, a large enough set of interesting things that you can, where there is an incremental aspect to the points, where you know what the order the points were inserted in. And that gives you a way of reconstructing it. Probably the simplest way to do that would be to do random walks. Suppose you build a data set by starting at a particular place and then do a random walk from that point in arbitrary directions. To what extent could you reconstruct, looking at the points, what order they were generated in? Okay, I don't expect you to be able to do perfectly, but I expect you to be able to do better than random. Okay? And I give you various possible questions here that you can answer on this. And as I said, I gave this last year. People didn't choose it. I still think that doing the random walk reconstruction is an interesting problem. Okay, and you guys can see what happens. Okay, and if you can pick this one, demonstrate that you can make, okay, enough data for a set of experiments, or get enough data to make it interesting. Okay, do some kind of baseline model to generate an order. Okay, come up with an evaluation showing how, measuring how good or bad your order is. What might be a statistic to measure? If I give you an order, if I have a bunch of points and I give you, you figure out an order of them, and I give you a reconstructed, the right order in which the points were inserted, how would you measure how good or bad you did? Can anybody come up with a statistic for that? Okay. What? Hamming distance? Hamming distance was for measuring how many positions you got exactly right. That's probably not quite as good, because again, if I had, you know, kind of moved one over and I had them all next to each other and they were, one was a slight shift of the other, Hamming distance would say that they were terribly, there was no association. But that would be pretty good if actually all I did was get the last point first. Okay, the Hamming distance would be, you know, infinite. But in fact, I knew the relative order of all of the points. Any other statistic that might work here? Yeah? Something like Spearman correlation sounds good to me. Okay? But we can just figure this out later. Any questions about this one? Okay? I'm getting down towards the end of the list. I know we're getting restless. Last year, I had a project where I had people try to take a text, in that case the book The Great Gatsby, and translate it so it didn't have any E's in it, a lipogram. You want to have the same book, it means the same thing, but it doesn't have any E's. Now I want you to do something even harder. I want you to take a sentence or two sentences and translate it into a palindrome that means what it means, roughly what those sentences mean. Okay? What is a palindrome? A palindrome is a sentence that reads the same forward as backwards. A man, a plan, a canal, Panama. That is a palindrome. The letters used are the same forwards and backwards. Okay? So my question is, a palindrome translation of a text is a rendition P such that P is a palindrome and it somehow is close enough, ideally, to the original text to have the same meaning. Okay? Any questions about that? So my question is, use an LLM to try to do this palindrome translation. Okay? I warn you, I don't expect the results to be great. Okay? But I do think that there is something interesting that can be done here. Okay? So doing this involves getting into the bowels of an LLM. Okay? And what would I want you to do? Okay? I would say, start out using chatbots and see what they could do with this problem. I expect if you do nothing, then just ask a prompt, I expect it will do a terrible job. But if you could train an LLM in the right way, or adjust the loss function in one of these in the right way, okay, you can kind of do something on here. Okay? Any questions about what I mean by palindrome translation? Okay, fair enough. There is a sort of an ongoing project I've had to try to gather interesting data about colleges and universities. If you go to the website skina.guide, you will see my guide to colleges and universities. Okay? And this was something based on data that we had obtained from about all interesting universities. Okay? And in this project, you are going to try to find and build some kind of an interesting new statistic about universities, or some other interesting new aspect of data of universities that you're going to try to find a way to measure from data sources. Okay? The important thing is that they have to be based on something that you can scrape or get on the web. They have to cover the full range of what I call universities. You can see what I call a university on my website. Maybe there's more schools than that. They kind of measure, your statistics should measure what it's measuring, okay? And that you can somehow validate that on some level. And that you can map them properly to university names and codes. So again, I give you a list of my data that I'm using. What kind of things might I want to know about? Can you measure the sports program quality of different schools? Okay? Now, knowing about smaller teams at colleges, like let's say the tennis team, okay? Not everybody knows, there's a lot of statistics covering the football team and the basketball team and rankings. My question, if you look at the broader set of sports, is there something interesting you can do? Okay? Because again, there are a lot of schools like Stony Brook which really don't have top basketball and football teams. The full depth of the program goes deeper than that. Can you measure it? Can you measure which schools have better teachers? Okay. And again, Rate My Professor is one website that does this. But can you, analyzing that data in an intelligent way is not trivial. Okay. Can you tell me how good a program is? How many of you came to Stony Brook because you heard it was a good computer science department? Few of you, okay? Who said it was a good computer science department? Don't know. Why did they say it was a good computer science department? Don't know, okay? Question is, if I wanted to know how good the programs are at different schools, is there a data-based way that you can do this that makes sense? Which schools have better quality rankings? And is there a way to generalize the data that I have maybe to international schools? If I wanted to rank Indian schools the way I do in the United States, is that a sensible thing to do? Is there a good enough data set where this is a meaningful comparison? Okay? So what do I want you to do? I want you to sort of figure out what questions you're interested in answering, what data sources you're going to use, prove you can get access to it, prove that you're not just doing something dumb like scraping one site and calling it a day, okay? Is there a way that you can update it and, make sure that there's enough work to do an impressive job building a complete data set here and analyzing it. If you're just scraping from one source, this is not very interesting. Okay? Any questions about that? Okay? And I think that's all the projects I am listing to. Any questions about the course projects or what I'm wanting or how you should proceed? Okay? Yes? The TAs are there basically to answer questions. So, the TAs, generally, with the exception of Jignesh's project, I came up with these projects and sentenced the TAs to be the leader here. So it's not that they have necessarily some know something about the domain. But your job is to figure out the project and questions and ideas. I encourage you to chat with the TA about. Maybe they'll have some ideas. Maybe they'll have ideas what other people are doing, things like that. Any questions? Yes?
Do some projects have an edge over other projects?
Do some projects have an edge over the others? What I will say is you saw that I gave some red and some black. I believe that the red ones have more of a range to do something, potential to do something interesting and distinctive. Now, is that an edge? It's not necessarily an edge, but if you've got an project where, what you're doing doesn't sound like it's going to be that exciting, quite likely it won't be that exciting, okay? And that's probably not going to get rated as well as one that is. On the other hand, if you have one that is exciting, but you have absolutely no idea how to do anything on it, that's a bad project for you. Does everybody agree? So, yeah.
So if you pick a boring project, but you complete it,
if you do a great job on a boring project, you will do great. Okay? And there's domains within every boring project that can be less boring. Okay? But it's probably harder. You have to make sure you can find that. Okay? And that may or may not, that takes some judgment and some experience and some thinking and some creativity. Okay? Yes? Can you use data? Yes, you can use whatever data sets you can find. Okay? Now, if you're going to tell me that you're going to do the educational project, and you're going to say, look, I found this data set on the web, and here it is. That's not a very interesting project. But on the other hand, if you have a better data set for one of these tasks, by all means, that's a great thing to do. Okay? Any questions about it? So think about it, and we can talk about it some more later on. Any questions? Okay, fair enough. So what I'd like to do from now on for today, I'm going to do a little bit of a shift from I'm going to permute the order of some of the lectures in here, just because the homework 3 seems to be dealing with things related to nearest neighbor methods. And so I want people, I think maybe it'll be more helpful if I talk about these kind of things now. And one of the things that again, you're faced with a, on homework 3, what is the purpose of homework 3? You will use some NLP model to turn documents into a point in space. You will use a vision model to turn images into a point in space. Now, what do you do with points in space? Okay? One popular set of methods for working with these things are nearest neighbor methods. What is the idea? Typically, it's a classification thing. Suppose, let's say, we have a bunch of training examples. Let's say if we wanted to do real nearest neighbor classification, let's say you have a bunch of examples of what is an image that is a car, what is an image of an airplane, what is an image of a, what were the other, cat. You may have some other, you have 10 classes in your data, right? You could imagine a world where the images you know of are points in space and they have labels. They can be used to carve up the whole space of possible points into regions such that you can assign every point in a region, okay, the label of its region. Here we've got red and blue points. If I have a point here that I want to know what color it is, how can I figure that out? Well, I look at which point is its closest neighbor. If that point is blue, I am blue. In this case, if its nearest neighbor is red, then I am red. Okay? And when you do nearest neighbor classification, ideally what you've done is you carve up the space into regions. The regions are not linear boundaries. So we're not dealing with like a, if we were going to have to separate this by a line, it would be a swoosh. You can have a more complicated boundary defined by this nearest neighbor thing. It's a high-dimensional thing, okay? And if you have a distance function that lets you find the distance between points, nearest neighbor classification is a simple method. It is relatively interpretable. If you take a look at a neural network and it comes back and it says this image is a car, okay, what do? Say, I don't know, the network said it was a car. That's a car, okay? Now, if you have a nearest neighbor thing and you take a picture of this guy in my class and you say he's a car, you're going to say, why is he a car? Well, you could take a look, you're going to get what is the nearest neighbor to him. And if you look at that, you'll say, yeah, that's a car, but it does look a lot like him, doesn't it? Okay? Now you've got some explanation, some interpretability, okay, and that I like. And the fact that the decision boundary can be kind of arbitrarily wiggly, this is a great thing. It means that you can fit your data in a nonlinear way. This is why I like nearest neighbor methods. Any questions? Okay. Now, one thing that nearest neighbors are good for, okay, is kind of enabling you to identify what items are like it or should be like it, okay? So one thing that you could do, for example, and I think I may sort of ask you to do this in your thing, is to look for outliers, right? I might ask you to say, which are the outliers? Which are the things that don't look like the center? Or I might say, for this particular car image, which are the ones that do look like it? If I can take a look at what the near neighbors are, I can usually understand what my representation is doing right or doing wrong. Okay, I think it's a great way to visualize representations. Now here is some data on websites classification that was done using two methods that happen to be from in my lab. That doesn't really matter. But what matters is, I want you to tell me which one is better. Okay? Is Deep Walk better than RandNE or not? Okay? And what is this doing? This is the elements in here are websites. And what this is showing you for a particular website, what were its nearest neighbors? Okay? So some of you may be familiar with stonybrook.edu, right? These are the 10 nearest neighbors according to one algorithm. These are the 10 nearest neighbors according to another algorithm. Which one does a better job? Does anyone have a feeling here? Yeah? Why is Deep Walk doing a better job?
Because it is grouping by sector, like same sector related purchase, Bank of America, Capital One, and so.
Well, if we look over here, let's look at the colleges one. Do you think the colleges are doing better? Which one's doing better for measuring, capturing similarity?
For colleges as well, because in the same region the colleges.
These are all New York colleges, right? These are other colleges. So somehow there's clearly a preference that it's capturing some locality. Is it better or not? I don't know, but it's doing something different, right? Which is more like Baidu? Does anyone know what Baidu is? Okay. Chinese company, right? Which one is it doing a better job capturing what a Baidu is? Is it Deep Walk or is it RandNE? Does anyone have an opinion? Say Deep Walk. Why is Deep Walk doing something better? Because you don't think Wolfram Alpha is like Baidu? Okay. Does anybody else have a feeling? I mean, I see Chinese companies here, right? I see Chinese internet companies, if I am correct, or marketing companies. If someone knows better, correct me, by the way. And here I'm seeing things that are reference sources, but are not clearly, I think of it more as an internet company, as a big Chinese company, than I think of it as a reference source. Which is better, Deep Walk or RandNE compared to Chase.com? Does anyone know what Chase is? It's a bank, okay? So which one is doing a better job? Okay, Deep Walk, okay? And what about Wikipedia? Which one looks more like it's matching what we would think Wikipedia sites are? Okay, I think these are reference sources that I know. This is that internet comic I told you about. That's great. Okay, so you can form an opinion of which method is better without actually a quantitative evaluation. Does everybody see this? If you understand your domain using this, even in the absence of a quantitative evaluation, you can have an intelligent sense of which one is better. That's one of the things I like about nearest neighbor kinds of things. Okay, any questions? Now these are TS&E plots, which is what I asked you to do on homework 3. How many people have built TS&E plots of what they are seeing from homework 3? Homework 3, okay? This is where I want to get a sense. This is what Deep Walk's clusters looked like. Again, these were internet domains. I colored them by what the last extension are they. Are they .edus, .uk's, .ca's? And I see clustering here. Does everybody see this thing? I took my, several hundred dimensional points. These TS&E plots are drawing them in 2 dimensions. Okay? and I see clusters. On the rand NE one, okay, do you see clusters? Look at this. Do you see clusters? I see clusters. Do I see as clean clusters? And the answer is no. Okay, but it's clearly non-random. Something is going on here. Okay, some of the clusters, okay, it's doing a very good job with. Others, it seems to be kind of fragmented. But even there, you see, like the pink one is fragmented and it's got some continuity. So my question for people who've been doing the homework, do you see a picture that looks like the one on the left, or is it much worse? What? Someone, people who've been doing the homework, I just want to get a sense. Who here has a TS&E plot of something from the homework? Raise your hand. Okay? Now, of these, is your TS&E plot much worse than the thing on the left? You should be holding your hand up if it's bad relative to this. Okay, so people are seeing bad things. Work this out with I'm not quite sure I know why that is happening. The picture I got wasn't so bad. Okay, so I want you guys to work this out over Piazza and stuff like that and make sure we figure this out. Okay, any questions about it? Actually, one thing to be impressed with is what is TS&E doing in order to make a picture like this, okay? It's taking your high-dimensional data and reducing each point to how many dimensions? 2. Now, think a little bit about how hard that is, okay? Can you reduce something from 100 dimensions to 2 dimensions without adding some form of distortion? No, okay? Assuming there's something in those dimensions. The fact that the two-dimensional projection here is preserving so much visual similarity is actually pretty amazing. Part of your homework is involving dimension reduction. You're going to be using SVD to kind of reduce the dimensionality here, okay? It's actually kind of amazing that there is still a visual clustering even after you take this high-dimensional thing and reduce it to 2 dimensions. Does everybody agree with that? So you should respect it, okay? Not expect it to be perfect, but it does sound like there's some kind of a problem here. Okay, any questions? Okay, good. So when you're using a nearest neighbor method, you need to have a sense of distance between points. Again, on some of the homework, you had to define some kind of a distance measure, okay, between things. What are the properties that a distance measure should have? Okay? We say that a distance measure is called a metric if it obeys the following properties, which you will all be familiar with from Euclidean distance. The distance between any two things is always greater than or equal to 0. The distance from me to you is positive, okay? When is the distance 0? The distance from me to me is 0, right? And that's what identity means, that the distance, we should know the distance is always positive. The distance between is only 0 when the points are exactly the same. The distance function is symmetric. I'm as far from you as you are from me. And the more complicated one, which is the triangle inequality. The distance from me to you, okay, is less than the distance from me to somebody else, plus the distance from somebody else to you. What does this mean? This is the as the crow flies idea. The straight line distance from me to you, the shortest one is as the crow flies. If I have to go out of the way for something, okay, the sum of the distances gets larger. The only way there is equality is if this point Z lies on the shortest, shortest line segment between X and Y. Any questions about that? So if you have a distance function that observes all of these properties, that is like Euclidean distance. And that is what we grow up thinking about distance functions as being. Okay, so our intuition about distances comes from things that are metrics. Now, many measures of similarity in higher dimensions and in regular are not metrics. Is the correlation coefficient a metric? 2 points, if you could, especially in high dimensions, if there was a perfect correlation between the two values, that would mean that the points are very, very similar, but the correlation coefficient goes from -1 to 1. So it's not a normal distance metric. In this case, actually, bigger, it's also not even a, really a distance function. Distance functions should get smaller as things get closer. Okay? There is a way to map a number that's in the range of -1 to 1 so that it becomes a number between like 0 and 2. Okay? Where further away, more extreme values would be far and high correlation would be low. But understand the difference between a similarity function and a correlation measure. Cosine similarity, which is the dot product of two vectors, also has the property that it goes from -1 to 1. And often in high dimensions, this is a very good measure to measure the similarity between points. On your homework, I believe, you were given the task of comparing your distance metrics, your points, with Euclidean metric distance and with the cosine distance. And we'll see how they perform or not. Any questions? There are other measures of seeming distance that are not metrics. Some of you may know about mutual information measures of probability distributions. The distance, but the mutual information from A to B is not the same as B to A for many of these things, so it's not symmetric. And if you think about the cheapest airfare, if you say that the distance between two places is the price of the distance, the cheapest airfare you can get between them, does that observe the triangle inequality? And the answer is often not. Often there's sometimes a way that if you're tricky, if you fly to an intermediate city, you can reduce the cost of the airfare. Okay? So some things are metrics, some things aren't. Okay? And, our ability to reason about these distances depends upon whether it's a metric. The most familiar metric that we are used to is Euclidean distance. What is Euclidean distance? The sum over all dimensions of the absolute value of the difference of the ith coordinate of one point minus the ith coordinate of the other. Square it, so it's the sum of squares of the dimensional differences, and you take the square root of it. Okay? This is what we use as a dimensional thing. Okay, most everybody's familiar with using Euclidean distance. Now, notice that there are other things we could do to this distance function if we wanted. Suppose we knew that some dimensions were more important than other dimensions. Let's say we're rating people, and we have one dimension is the length of their toenail, and the other was how smart they were. Okay? Intellectually, we would say that maybe we care more about the similarity of their IQ than their toenail length. Okay? If so, you could conceivably generalize this by multiplying each dimension I by a coefficient. So you could weigh certain different dimensions differently than others. That would still leave a metric, okay? So that's still fine. Now, the big problem on using distance is, if you've got these things, is if the dimensions are not comparable, okay? If we have you as a thing where one of your dimensions was IQ, and that's a number between 1 and 100, and we had another dimension that was, let's say, your gender. It was 0 or 1, depending upon whether you were male or female. Those would both be important dimensions, but by definition, the one which had the bigger range is going to make a bigger contribution to the distance. This is why we talk about z-scores and normalization, okay, to make sure that if you're going to compute the distance between points, you have to make sure that all dimensions have comparable magnitudes, or else you're going to have a weird result. Any questions? Yes?
How do we know if they are strongly related to each other? Does it mean let's say features A does not have any relationship with feature B, so it's not fitting into this count?
Okay, so there's two different issues that we're talking about here. I think you're talking about correlation between features. What happens if we have two features that are highly correlated with each other? Let's say one dimension was the length of your left toenail, another dimension was the correlation length of your right toenail. Okay? These two are probably going to be highly correlated. What happens when you compute the distance of it? Well, they're being treated equally, so toenailness is going to be getting twice as much vote, let's say, as IQ under that case. If you have one column for IQ, you have two very highly correlated variables. When we're computing the distance here, we're not taking the correlation of the columns into account, okay? So if you have a large number of highly correlated features, they will come to dominate the distance metric. That could be a problem, okay? That might be an argument that before you compute the distance, you do some kind of dimension reduction to eliminate. We'll talk about dimension reduction later, but that might be the concern you would have there. Any questions about that? Now, there is a generalization of Euclidean distance that is natural and important to know, which is that that our Euclidean distance was the differences of each dimension raised to the second power, sum up that, and then take the second root by raising it to the 1/2. That's what the square root is, right? Note that this is well defined if we use a different value of k here. Euclidean distance is what we would call the L2 distance because k is equal to 2, okay? But there are other values of k that are interesting. What happens if we have k equals 1 in a distance metric like this? That's going to be the sum of the absolute differences raised to the 1th power, which means it underchanged. Basically, this is the sum of the dimensional distances, okay? This is called the Manhattan distance because this is how far you walk on a city grid, right? Does everybody see that if you're in Manhattan, you want to go from here to there? The shortest distance according to the Euclidean distance is to fly through buildings. Can you fly through buildings? Unless you're Superman, cannot fly through buildings, right? You can only move down the north to south or east to west. And so what is the distance from here to there? It's the number of blocks to the west plus the number of blocks north that you have to go to, okay? That is exactly what the L1 distance corresponds to. What does the L infinity distance correspond to? What happens if I instead say, take the sum of the distances of things, raise every difference to the infinitieth power. If you don't like infinity, say extremely big, right? And then take the infinity, the infinitieth root. What is going to be left from that? Does anybody have an intuition? Let's think about it. If you have, a bunch of differences here, let's say that difference, this difference, this difference, this difference, this difference. This one is bigger than all the others. If you raise each of these to the infinitieth power, this is going to be much, much bigger than all the others. Does everybody kind of see that? If I squared it, this would be something like that, this would be something like that, right? So when you raise them to a high power, the biggest one is going to dominate all the other terms, right? And if the other terms are bupkis next to it, okay, if you then take the infinitieth root, you're only going to have basically the largest distance, dimensional distance. So K1 gives you K infinity gives you the maximum difference between things. Any questions about that? Why do we use the K equal 2 in our world? We could have lived in a world of Manhattan where everybody measured everything in terms of L1 distance. Why is it that we use the Euclidean distance in our life? Does anyone have an idea? Basically, it's because we like the Pythagorean theorem. That's the way I would think about it. That we're kind of used to this idea that there is a diagonal kind of cuts things off, okay? But there's, it's not immediately obvious that the world had to take 2 as an assumption. And depending upon what dimension distance measure you use, that will change what you find as a nearest neighbor. Remember, we're interested in nearest neighbors. Is the point 2, 0 or 1.5, 1.5 further from 0? Okay? If we had k equals 1, well, the sum of the dimensional differences here is 2 versus 3, so this point is closer. Okay? If we had one where we were measuring the maximum difference, I think I got this backwards. Did I have this backwards? Okay, for Euclidean distance, this is 2. This is going to be 2 times 1.5 squared. Okay, this point is further from it. So as opposed to closest. So the further point from 1 in a Manhattan distance, this is further from the origin than that. In Euclidean distance, this is further than that. For the K infinity norm, okay, we look which has a bigger dimensional difference. The x dimension is bigger, so P1 is further from the origin. So basically, if you want to do nearest neighbor, you got to specify your distance measure, and you got to decide which norm is better for you. We're used to using k equals 2. That's probably a good first try. But there's going to be a difference as to whether you're worried about random noise on each dimension, or are you worried about big artifacts of outliers between things. If there's certain dimensions being out of whack, means everything, they're really far away, maybe you want a higher k than others. Any questions? Which of these are circles? I'm showing you what a circle is. What is a circle? A circle is the set of points that are equal distance from a center, right? This is what we are used to